lesson is called Similarity and Measurement. This time we have 3 vocabulary terms and 3 examples to work through. Let's take a look at our vocabulary. They're all a review. First we have a ratio. Remember, a ratio is a comparison of 2 numbers using division, aka a fraction. Next we have a proportion, which is an equation which states that 2 ratios are equal. We also call that a set of equivalent fractions. And then similar figures, which we learned in our last lesson. Similar figures are figures that have the same size, though not they have the same shape, though not necessarily the same size, and their corresponding angles are equal in measurement, and their corresponding sides are proportional. Now this lesson's a little bit more complicated than the previous one, and so what I did to make it a little easier and easier to follow is I have a list of steps that you'll need to follow for the examples in this lesson. The very first thing you have to do when we are talking about sides and similar figures and their measurements is that we are going to start by writing an empty or blank proportion, so basically one fraction bar equaling another fraction bar. After we have that, we are going to fill in the names of the corresponding sides, numerators and denominators on both sides. After we have identified the corresponding sides, we will rewrite our proportion underneath it, but this time filling in the numbers that show us their side lengths. Then, just as we did a few lessons ago in using the method to cross-multiply to solve a proportion, that's what we'll do. We'll cross-multiply, and then what we'll do is to divide both sides by the coefficient to isolate the variable. We are going to follow these steps as we work through our 3 examples today. Now this is the easiest example of all, and I did that on purpose. So given that triangle STU is similar to triangle XYZ, we need to find the length of side YZ. So as our first step states, we're going to start by writing an empty proportion, and then we'll jump to step 2, which is to identify and fill in our corresponding sides. Let's start with this side length. We'll call this side SU. We'll put that in the numerator. And in the denominator, what we'll do is we'll put the side that corresponds with SU, and that is side XZ. Next, we'll work on the base. This side we'll call UT, and then the side that corresponds with it is ZY. And I like doing this first because then it makes it easier to just fill in the values, and we can make sure that our proportion is set up the proper way. So our third step tells us to rewrite the proportion, but this time we are going to fill in the value. So side SU has a length of 12 inches. Side XZ has a length of 30 inches. Side UT, which is next, has a length of 14 inches. And we don't know the length. That's what we have to find of ZY, so we are going to fill in an X. Now maybe you notice that we're tasked with finding the length of YZ, and here we're finding ZY. The letters are interchangeable, so when we talk about side ZY, we're also talking about side YZ. So going on with our steps, our next step is to cross-multiply. So that means we'll have 12 times X equals 30 times 14. After we write out what we have to multiply, we will simplify. 12 times X is 12X. 30 times 14, well, that's 420. Our last step tells us to divide both sides by the coefficient. In this case, it's 12. And then when you do your long division, you'll find that x equals 35 inches. And if you wanted to check your answer, what we could do is go back to our proportion and this time fill in all the numbers that we have. So 12 and 30, and then 14 and 35. And there are a couple of ways that we can do this. We can either cross multiply the two, and when we multiply 12 times 35, you would find that you get 420. That would be equal to 30 times 14, which is 420. Maybe what you'd like to do instead is to simplify both fractions. And here, the greatest common factor of 12 and 30 is 6. So once you divide a 6 out of the numerator, you would get 2. And when you divide a 6 out of the 30, you get a 5. Over here, 14 over 35, their greatest common factor is 7. There are 2 7s in 14, and there are 5 7s in 35. And as you can see, they equal each other, so we know that our answer is correct. Now, our second example is a little different. I'll read it to you. This man's height and shadow length are proportional to the height and shadow of this flagpole. Find the length of the flagpole's shadow. So this is more of a real-life application of the same skill, but we're going to be following the same exact steps that we just did to solve example 1. The first thing we're going to do is to fill in our blank proportion, and then we'll start filling in our corresponding sides. But here what we're talking about, instead of sides of figures, are the heights of a man and a flagpole and their shadows. So here we know that the man's height, so we're going to talk about the man's height, I'm just going to abbreviate it, and that is proportional to the flagpole's height. And then even in the numerator, since we're talking about the man's shadow length will be in the numerator here, and in the denominator will be the shadow of the flagpole. Next, what we do, according to our steps, is we fill in the numbers that we know. The man's height is 6 feet. The height of the flagpole is 15. The man's shadow is 2 feet across. And we do not know yet the length of the shadow of the flagpole. Next, we'll cross multiply. 6 times x, which is 6x. 15 times 2, which is 30. Then we will divide both sides by the coefficient 6. And we learn that x equals 5 feet. So your final answer to this word problem will be that the shadow of the flagpole is 5 feet long. And in our final example, I don't want for you to feel startled or intimidated by the way that it looks. The only difference between this problem and our first example is that instead of having the triangles separated from each other, one is inside the other. But nothing else is different. All the steps will be the same. First, we have to know that triangle LMN, so here is LMN, so it's the larger of the two triangles, is similar to ABN. So there inside is that smaller triangle. And since they're similar, it means that they're proportional. We have to find MB. And I'm sorry, I forgot to write in the measurements. We know that this is 9 inches. The height of AB is 6 inches. The length of LM is 10 inches, and we do not know the length of BN, also MB. But the steps will stay the same. First, we're going to set up our proportion. Here's where it might get a little complicated, but just stay focused on one triangle at a time. Let's start with what we know. We know the length of LM. LM is the side length of this triangle. Side AB corresponds with it. Okay, here's the tricky part. Since we're working with LMN first, LMN, we need to know the base. Now the base is named MN. And then the base of triangle ABN is BN. Do you see that? The name of the larger triangle, the base of the larger triangle, goes from point M all the way to point N, MN. And then the base of the smaller triangle, the corresponding side, is BN, B to N. Now what we'll do is fill in what we know. We know that side LM has a measurement of 10 inches. We know that AB is 6 inches long. MN. Well, this is a little tricky because MN is broken up into two pieces, but we know what they are. We know that one piece is X, and we know the other piece is N. So the sum of these two pieces will give us the total length of that side. And then we're looking for BN, which is 9. So the hardest part really about this kind of a problem is setting up your proportion. But again, if you go slowly and always identify your corresponding sides first, that will make the second step much easier. Now we're going to cross multiply. What does it mean? It means 10 times 9 equals 6 times, now remember what I said when we first learned about solving proportions. When you have an expression in either the numerator or the denominator, enclose it in parentheses. Because if you don't, you might forget to use a distributive property. So always, it bears repeating. When you have an expression, not just a single variable, but an expression in either the numerator or the denominator, and you're using cross products, please put it inside parentheses. Now we have 10 times 9, which is 90. Distributive property means 6 times x, which is 6x. And then 6 times a positive 9, which gives us a positive 54. Now what we have here is a two-step equation that you first learned about in the fall. What we have to do is negate the constant first. There are two numbers keeping the x from being alone, so we get rid of the constant first. That means putting a negative 54 on both sides. (90 minus 54), well, that gives us 36. This positive 54 and the negative 54 make a 0, and we're left with 6x. Then our final step is to divide both sides by the coefficient 6, because we want for x to have a coefficient of 1. And when you do your division, you find that x equals 6 inches. So the length of BM, or MB, is 6 inches.